So good afternoon, everybody. I am Meriem Hamdi-Cherif, environmental economic researcher at the French Economic Observatory, or FCE, at Sciences Po Paris, and I am very happy to chair this transportation session of the 25th annual conference of the GTAP. I would like to thank in advance the host of this session, Dr. Alla Golub, who is research economist at the Center for Global Trade Analysis at Purdue University, and who will kindly manage this 11th session. Actually, for the next 2 hours, we will have the pleasure of listening and discussing with Byeong-ho Lim, who is researcher at the Korea Maritime Institute, Francesco Clora, who is PhD fellow at the Department of Food and Resource Economics, Faculty of Science of the University of Copenhagen. Then Andressa Proque, who is professor at the Federal University of Juiz de Fora, Minas Gerais. Sorry for the pronunciation, in Brazil. And finally, we'll have the pleasure to listen to Zhan Wang, who is PhD candidate at the Department of Agricultural Economics at Purdue University. Let me kindly remind you that each presenter will have 20 minutes for his presentation and 10 minutes for the discussion with the other presenters and the audience that who maybe will join us later. Alla, our session host, will verbally prompt the presenter when there are 2 minutes remaining in their allotted time. And we will have 2 minutes transition between each presentation. So please, Byeong-ho, the floor is yours to present a paper that is entitled Re-Evaluation of Free Trade Agreement based on Regional Value Content in Agricultural, Fishery, and Livestock Products.
Okay.
Please.
Can you see the presentation? Okay. Thank you very much, and thank you. And it's really nice to meet you all in 2022 GTAP conference. And as Meriem introduced, I'm working at Korea Maritime Institute, which is a national institute researching on maritime and including fisheries and oceanic economies. And the reason I present the issue of free trade agreements, I'm charged of estimating the effect of free trade agreement, especially on fishery sectors. Korea has strengths in manufacturing, but weaknesses in agriculture, fisheries or livestock, the first primary sectors. And we need to calculate the effects of free trade agreements when we conclude the FTAs with major trading partners, especially USA, the EU, European Union, or China, which are strengthening agricultural sectors. So it's very important for Korea to estimate the effects of free trade agreements, and especially in fishery products. And I found that the existing methodologies in evaluating the effect of free trade agreements, I think there are some errors, which is overestimation. The effects we estimated for the first time in advance before the free trade agreements was somewhat overestimated because they, I mean, the pre-existing methodology does not takes into account the tariffs. I mean, the rules of origin should be considered when we implement the free trade agreement, but they did not. And in this simulation, I developed a new model, a kind of new model that include the rules of origin, and I could calculate the value of other types of preferential tariffs. And I found that there were overestimation. And in this new model, in this another version of model, I could calculate the correct value of effects of free trade agreements. So this was the background of this thesis, and I should tell this is ongoing research. So I will show you the results, but this is not the final version of the results. I can adjust and I can modify the research methodology. So if you give me a comments, and I proceed in firstly introduction and literature review and the re-evaluation methodologies and research results. Firstly, I should tell this to Korea notified FTAs with more than 20 economic partners, and recently Korea joined RCEP, which is often called mega FTA, including China and Japan. And this is a new type of free trade agreements, and also concluded FTAs with US, EU, and China. And this is a eighth in the world in terms of number of free trade agreements. But in terms of FTA utilization rate, I should tell this, the FTA utilization rate is the actual rate of the corporates used free trade agreements. They can choose preferential tariffs or just MFN tariffs. But the utilization rate is the ratio of when they chose the free trade agreements of FTA tariffs, preferential tariffs. The ratio is New Zealand 42%, Vietnam 44%, is ASEAN 54%, China 64%. These FTAs are relatively low, below the average. And in terms of sectors, agriculture, forestry, and the fishery sectors are relatively low sectors, below the average. Average is around 80%. So why is this happening? I should tell there have been errors and overestimation when they evaluating. When they evaluate the effects of free trade agreements, and especially the rules of origin, they need to consider the existence of rules of origin. Without considering the rules of origin, application utilization rate assumes 100%, which means every shipments from exporting country is under the scope of free trade agreements without whether they qualify the rules of origin or not. So the existing methodologies need to be modified. And in this paper, I suggested RVC, regional value contents. I'll tell you in detail the concept of RVC. This reflecting RVC will correct the estimation of free trade agreements. And the literature reviews the common methodologies to analyze the FTA. there are no common methodologies, but mainly when they evaluate the effects of free trade agreements, they mostly consider 4 steps. Firstly, tariff reduction and price down, importing price down, and trade creation and production expansions. This is mainly caused by lowering importing tariffs. And the tariff costs have the price of export products lower and increase demand, importing demand and real value. These are traditional methodologies when they evaluate the free trade agreements, and CG modeling is widely used because they need to consider the interrelation between the trade creation and also trade diversion. So when it comes to free trade agreements, trade creation and trade diversion between every country in the world happens at the same time. So we mostly use CG modeling. We sometimes can use partial equilibrium, but when it comes to free trade agreements, we use CG modeling, and I also used CG modeling too, but I used modified version of GTAP HS and GTAP VA model at the same time. Still, I'm talking about the existing model. There have been limitations when the evaluation of free trade agreements. Export increase not equal to GDP growth all the time. Gross exports is not directly connected to GDP or job increase. That's because gross exports also comes with importing increase. And so when we talk about the change in GDP or job increase, we need to take into account the value added created within a single country, exporting country, and its contribution to its growth. So the key questions of this paper is, would tariff reduction be fully reflected in importing price change? In order to correct the estimation errors, a tariff need to be calculated upon domestic value added, which is DVA. And this DVA should be calculated again using rules of origin. Every free trade agreements has rules of origin agreements, and we need to consider that to recalculate the level of tariffs. And the IVC can be calculated by DVA and rules of origin, which are the ratio of the domestic value added ratios against the rules of origin. I'll tell you in detail later. So, and another assumption is that the impacts of free trade agreements have been overestimated, especially agricultural, fishery, and livestock sectors, because they have high import rates. As you all know, agricultural, fisheries, and livestock sectors, I think most countries in the world has high tariff rates because they are sensitive, and their the competitiveness is weak, and there are many labors in those sectors. So that's why they have high import rates to protect their sectors. And second one is wholly obtained criterion, which is one of the rules of origin. The exporting products need to be created. The value added need to be created within a single exporting country. And third, exclusion from participation in GVC. This is somewhat similar to the second one. The agricultural and fishery and livestock sectors, there are no chances to use global value chain because they have WO rules of origin, and there are no importing intermediates. They use wholly domestic intermediates. So that's why they are excluded from the global value chains. And when I calculate the effects of free trade agreements, I needed to select the WO products. As you all know, the wholly obtained rules of origin are classified in HS 6-digit. So I need to use GTAP model, and at the same time, in order to evaluate the regional value contents, I need to also GTAP VA model at the same time. And these are the big pictures of this model. Firstly, I used GTAP HS data aggregation for items for agriculture, livestock, and fishery products, only for wholly obtained products in FTAs of Korea, China, Korea, US, and Korea, EU free trade agreements. And I only selected the items of wholly obtained products. And secondly, I want to use GTAP VA model, but after GTAP HS data aggregation is totally different from GTAP HS version. So I downgraded. I mean the GTAP version is different. So I modified the data to apply GTAP VA model for agricultural products. And I inverted the value of products. And finally, I estimated the free trade agreements using tariff elimination between Korea and other trading partners. And these are the main risk methodologies. And I suggested two kinds of methodologies. Existing methodologies, they use TMS and CIF. When we calculate the market price, we use importing price and importing tariffs. But these tariffs, when we change the TMS, we do not consider the value of rules of origin. In this new methodology, I used TMSO. I added O, which means origin. And TMSO can be calculated by RVC and ROO. And RVC cannot be higher than rules of origin, because when we more regional value contents than rules of origin, we just apply whole of TMS, wholly importing tariffs reduction. And when we use the value of RBC, I only used bilateral domestic value added. I did not use multilateral domestic value added. That's because when we talk about the free trade agreements, we do not consider the products from the third party country. We only use the bilateral relations. We only consider that. So I only used bilateral domestic value added. And these are the JMPEG code for IVC calculations. The IVC is basically the ratio of domestic value added out of total exports. And I used IVC dummy. These are the ratio of IVC against rules of origin. So as I told you, when IVC is over rules of origin, they are equal to 1. And when they are lower than rules of origin, I use the ratio of region value contents against rules of origin. And this is the calculation of TMSO. When I actually use the change of importing price, I replace TMS to TMSO. And the TMSO can be obtained from the IVC dummy and TMS. TMS is the original value of tariff change. So finally,
2 minutes. 2 minutes. You have 2 minutes left.
TMS, okay. And I can see we can obtain the value of PMS by using TMSO and PCIF. And these are the distribution of rules of origin in agriculture, fisheries, and livestock products of Korea's FTAs with China, US, and EU. As you can see, the 806 items among 972 items are applied to wholly obtained. So I used wholly obtained rules of origin in estimating the effects of agricultural products. And these are the results of analysis. The base data is the initial importing value, and the right side, previous model, and this model is the results of estimation, free trade estimation. And differential is the difference between the model A and B. And as you can see, the FTA estimation of Korea-US is the biggest, 74.1% of the original value of importing. So I should say there are overestimation errors in Korea's FTA, especially for Korea-US FTA and for agricultural sectors. So this is the conclusions. The key point is that their 100% utilization rate of FTA is unrealistic. It's not possible. We need to consider rules of origin, and we need to adjust the importing tariff rates. And that's because the existence of wholly obtained products for agricultural, fishery, and livestock sectors, there are hardly a very low chance of using importing intermediates. They only use domestic goods, domestic inputs. So that's why we need to consider domestic value added. And the next topic I want to suggest is about RCEP, CPTPP, or possibly IFF, the mega FTA. There are many members of free trade agreements, and the overestimation can be larger than before, or when we do not use the modified model. And when the level of ROO rise, the overestimation can be higher than before. That's because the rules of origin is determine the ratio of regional value contents. Okay, that's my presentation. Thank you. So if you have any questions or comments, please.
Thank you very much, Byeong-ho. Is there any question? Maybe, yeah, Zhan, sorry.
Yeah, thank you very much for the...
Sorry, maybe Byeong-ho, you can stop sharing your screen so that we can better see. Yeah, thank you very much.
Okay, yeah, thank you very much for the wonderful presentation. And I just have a clarification question about, so what is the baseline year of the GTAP database HF and the way do you use?
Okay, the baseline is the initial value of importing value of Korea between Korea and US, and Korea, China, and Korea, EU.
In which year?
It's the original GTAP data. I did not change the value.
Yeah, I have this question because I know the most recent GTAP released the version 10. It has the baseline year of 2014. And I wonder, do you think that if we consider the current impact or the future impact of the trade agreement, will the baseline year reflect what happened now, or maybe we should do some changes on that to reflect how will be the current and the future impact of the agreement?
Right. That's a very good comment. I used the original GTAP data, and the reference is 2014. I use this value because this is the estimation. I want to bring up the estimation error, and the year of FTA conclusion between Korea US is 2012, and Korea EU is 2011, and Korea China is 2015. And when I say the overestimation, I should recalculate the value of importing value or exporting value of the first step. I mean the first year of free trade agreements. So that could be 2012 or 2011 or 2015. So I just used the reference year of 2014.
Okay, thank you very much.
Any other question? Maybe I have some, and sorry if it's a stupid question because it's not my field actually.
No.
But what are the policy implication of such a reevaluation, re-estimation of this kind of parameter? Because I don't, yeah.
Okay, I should tell you. The fishery sectors for Korea, and there are three sectors: the agricultural, manufacturing, and fishery sectors. Those are three main sectors of free trade agreements. And the Korean government made a supporting program especially for agriculture and fishery products, because they are weak sectors. There are no competitiveness. I mean, the global competitiveness. Comparing China or EU or USA, they have competitiveness in agricultural products. So we prepare a supporting program. We want to raise our competitiveness in agricultural sectors. So after free trade agreements, we calculate the damage of domestic production, and we calculate that, and we use some the supporting program to other such as educations or subsidy or other kind of supporting program. So it is important to calculate the correct value of effects of free trade agreements before we initiate the free trade agreements.
Thank you.
Thank you for your question.
So, if there are no additional questions, we will thank again Byeong-ho Lim for his very nice presentation. And now we are going to move on to the presentation of Francesco Clora, who will present us a paper that is entitled International Maritime Shipping Decarbonization Under Alternative Technological Scenarios, Effects on Agri-Food Market. Please, the floor is yours, Francesco.
Thank you, Meriem. You can all hear me fine, right? And you can see. And you can see my screen.
Perfect.
Great. So let's get started. Hello, everybody. I am Francesco Clora, as a postdoc at the University of Copenhagen. And this work has been in collaboration together with Professor Zhan, also from the University of Copenhagen. And today, as Meriem has said, I will talk about decarbonization in the maritime transport sector under different technological scenarios, and what are the effects on agri-food markets. In the last 20 years, overall trade costs in agriculture have been decreased by almost 20%, with differences across various countries and differences also within subsectors. The drivers in these trade cost reductions have been mainly trade policy and trade policy, as in reductions in tariffs or reduction in non-tariff barriers, and decreases in transportation cost. And decreases in the transportation cost have been specific to some bilateral trade routes for specific modes of transportation, as in land, sea, or air transportation, and also specific to some other commodities. What we see in most analysis in literature, most analysis focus on trade policy effects on the economy. So, for example, they model the reduction or the implementation of a specific free trade agreement between two countries. What we do in our paper in this research is that we model the effects of changing transport cost on some specific markets, in this case is the agri-food markets. Before going a bit further into the study, let's also look at some data and differences in international margin usages at the global level by specific commodity groups. And here the data I'm showing are from the GTAP V10 database. So we see that most goods are transported across countries by water, so between 45% and 83% in different commodity groups, and they're also transported by air, by land, sorry, between 13 and 48%. For now, air transportation plays a relatively minor role at the aggregate level. However, it has air transportation usage has been increasing in the past decades, and this is also important for some specific, some more commodity-specific transportation across different countries. What we see here is also that cereals and oilseeds are transported mostly by sea, and this indicates some more long-distance trade routes. So you can think, for example, of soybeans being exported from the US and Brazil towards China, whereas animal food instead, but also vegetables and fruits, are transported both by sea and by land. And this also indicates more regionalized trade volumes, with the trade volume being also very high within the EU. So transportation between EU countries happens to a great extent also by land. But then when we move towards, so we can zoom in a bit more into one specific commodity group, and we observe that shares of margin usages tend to be a bit similar across countries, but are not exactly the same. So, for example, here we can look at international margin usage by the US oilseed exporters in 2014 towards different countries. And we see that maritime transport plays a major role in transporting soybeans from the US along each trade route. And we can also see that most of the exports, as we know, are directed to China, with approximately 14 billion in 2014. And the trade happens mostly via sea. Whereas we also observe that, for example, trade of exports of soybeans towards North and Central America from the US is still mostly happens by sea, but also happens to some extent by land transportation, due, for example, to soybeans transported from the US to Canada by trucks or via rail. Here you can also see that some transportation happens via air routes, but this is mostly due to very low trade volumes and along the specific route where we see this, and this is potentially indicated some imperfections in the data. So all in all, what we have seen in the previous two slides, most goods are actually transported by sea, And this means that changes in maritime transport costs in the future will affect costs along the various trade routes for some specific commodities. And in the future, factors that are affecting maritime transport costs are expected to be different technological advances, such as in logistics or changes in infrastructures and so on. The opening of new trade sea routes, for example, due to climate change, the North Sea route is more and more available throughout the year. Disruptions to different maritime choke points, partially due to either climate change, so increased extreme weather events, but also due to various political instabilities or potential political instabilities. And last but not least, transport costs will be affected by efforts in reducing emissions in the maritime transport sector. In 2018, the maritime sector contributed to approximately 2.8 of the global greenhouse gas emissions, according to the IMO, the International Maritime Organization. And greenhouse gas emissions are actually expected to increase by up to 44% by 2050 compared to that date. However, the IMO aims at reducing greenhouse gas emissions by the world fleet by 50% in 2050 compared to 2008. So they're actually aiming to reduce these emissions, not to reach carbon neutral, but to still reduce this emission. And some of the potential measures that are often mentioned to reduce emissions in the industry are different types of carbon levies, but carbon taxes, but also changes in energy efficiency or various fuel mix or changes in load factors and so on. So, as I mentioned at the beginning, what we do in this study is we try to answer the question, how can decarbonization in the maritime transport industry affect trade patterns in agri-food sectors, and how alternative technological developments can affect these results. So we focus on the decarbonization efforts and on some specific technological advances. To do so, we used a modified version of the recursive dynamic GTAP model. And the model has been modified by adding two greenhouse gas emission trading systems. So the first one implements a world carbon tax on the maritime transport sector, whereas the other one, the other set of equation allows model users to target some region-specific emission reductions in the rest of the economy. We also add a cost-neutral twist preference specification in each of the nests of production structures in GTAP. And this is done to better characterize structural changes within each sector. So, for example, to capture some exogenous shifts away from fossil fuels for specific industries towards other types of fuels. Also, quite relevant for this study, we allow for model substitution in the bilateral demand for transport services in international trade. So we move from the Leontief specification in GTAP towards a CES specification. And last but not least, we allow the INCPAR parameter to change, and we regress it on GDP per capita growth, leading to falling income elasticities of food items and rising elasticities for services over time. The model is calibrated on the GTAP Power and the GTAP non-CO2 databases for 2010, with 13 regions and 24 sectors. So we start by developing a baseline, so starting from the year 2014 towards the year 2040, and we do so by imposing onto the model changes in GDP, population, labor force, compatible or in line with SSP2 projections. We assume some increases in energy efficiency and some decreasing trade costs along bilateral routes. And we also target changes in greenhouse gas emissions for each region and for each region. So in the for the maritime industry, so maritime transport industry, at the worldwide level, emissions follow the IMO's average SSP2 projections. Whereas for the rest of the economy, each individual region reduces or follows emissions close to historical patterns until 2018. Then from 18 to 2030, we target each individual country 2030 emission goals. And then from 2030 to 2040, each country imposes yearly reductions in line with 2050 climate pledges. Against this baseline, we evaluate 3 core scenarios. And in this scenario, the efforts are starting in 2020. The effort to decarbonize the industry are starting in 2025. Oh, that's what we assume. So in the first scenario, we assume we target greenhouse gas emission reductions in the maritime transport sector. Compared to 2040, emissions are reduced by 46% compared to the baseline in 2040. This is in line with the IMO's goals of minus 50% in emissions by 2050 compared to 2008. In the second scenario, and we do so by using an international emission trading system. In the second scenario, we exogenize the carbon prices obtained from the first scenario, and we assume further technological development in the sector. And compared to the baseline in 2040, energy efficiency increases by 9%. Capital efficiency, so the increase in load factors, changes by 6%. And we assume a dropping cost share of fossil fuel by 20%. These technological changes is imposed at the global level, and these are within the boundaries of what is deemed possible by several pieces of literature. And in the third scenario, we build the third scenario starting from scenario 2, and we assume improvements in maritime logistic performances along specific and bilateral trade routes. So these are assumed to follow the baseline GDP per capita growth starting from 2025, and are based on the World Bank's 2018 Logistic Performance Index data. So we have these 3 scenarios, and let's look at some of the main results. And yeah, I have to say that these results are still preliminary results, so this is still an ongoing work. So we start from world aggregate, and we compare the policy compared to the baseline in 2040. So as I've said, emission in scenario 1, water transport emission at the global level are reduced by 46%. And further technological improvements keeping the same carbon price lead to actually as expected, lower emissions. In all the 3 scenarios, the output is reduced compared to the baseline in 2040. And this is due to increases in water transport prices that we can see in the following row, but also different technological improvements in the sector and along specific trade routes. All in all, from an aggregate perspective, global emissions are reduced by approximately 1% in all 3 scenarios, whereas real GDP is reduced between 0.35 and 0.26 compared to 2040. So GDP is still growing, but is growing a bit less compared to 2040 in the baseline. Total exports are reduced reduced more than GDP, and this is due to increase in transportation costs, hitting mostly trade flows. And we also calculate changes in global agri-food exports, which are decreased even more. And this is due to slightly higher reliance of agri-food exports, agri-food trade on water transport, compared, for example, to manufacturing. So now let's look at changes at the regional level, still comparing to the baseline in 2040. So on the left-hand side, we see the percentage change in maritime transport emission. And we can see the range of emission reductions across countries. And we see that this varies quite significantly, ranging from minus 40% compared to the baseline to minus 65% in scenario 1, with minus 46% being the reduction at the world level. The main driver of differences across countries are the sectoral emission intensities. In the figure, when we move to the figure in the middle, we can see the change in maritime transport emissions in absolute terms, so in terms of megaton of CO2 equivalents. And we see that the 4 bigger emitters in our baseline are the ones which are actually reducing their emission the most in absolute terms. So we have EU, China, East and Southeast Asia. And this happens along all 3 scenarios. We also note on the last figure here, we also note that global changes in real GDP can be disaggregated. Well, there are some differences across regions, and not necessarily the most affected countries are the ones that reduce their water transport emission the most. But these changes in real GDP also depend on countries' reliance on export and on trade in general. Also, one thing that we notice in these graphs is that the regional distribution of the effects, the global effects, is not significantly affected by increased technological changes in scenarios 2 and 3 compared to scenario 1, at least for these world aggregates. We also look at the percentage change in agri-food export compared to the base in 2040. And we noticed that, according to our simulation results, the increased international transport cost can lead to a decrease in the global export of agri-food products by approximately 2% on average in scenario 1, and by approximately 1.3% in scenario 3. And we see a similar pattern in that across each sector. However, what we also see is that each sector is affected differently by a reduction in emissions in the water transport sector. So we noticed that the higher the share of maritime transport usage, the stronger is the reduction in merchandise export for most sectors. So, for example, on the left of this figure, we found that sector that use less maritime transport margin. So we have non-ruminant meat, milk and dairy, other food, and ruminant meats. Whereas as we move towards the right, we find sectors that use maritime transport relatively more. Something that is not shown in this figure, but we also observe in our simulation results, is that reduction in exports are stronger than reductions in output for all scenarios and all sectors. So we can draw some preliminary conclusions based on the preliminary results. First of all, reducing greenhouse gas emissions from the maritime transport sector can lead to low reductions in real GDP and slightly higher reduction in global exports. Maritime transport emission reduction and GDP losses are shared across regions and are shared differently. And good exports are affected differently by maritime transport decarbonization, and this mainly depends on their international margin usage. Looking into future research, what we aim at doing, or what we will be working on, is on 3 fronts. So the model, the baseline, and the scenarios. So in the model, at the model level, we will include sector-specific model substitution elasticities in the newly added equation, and these elasticities are estimated by a recent paper by Avetisian and Ertel in 2021. So to go some even more differences across the effect that changing transportation costs can have on different sectors. Another thing could be modeling investments which are needed to achieve structural changes in the maritime transport industry. Another addition could be an improvement in land specification, since we're looking mostly at agri-food products. So, for example, we could follow improvements made in the GTAP AZ model. And last but not least on this side is we could separate freight from passenger transport, which have different decarbonization potential. And actually, in regard to this, on Friday, there is a presentation from some researchers at the European Union Joint Research Center in regard. What we can improve in the baseline, so what further research in the baseline could be an improvement in the representation of sector-specific development in the maritime transport industry. So, for example, some technical efficiencies, some fuel mix, some infrastructure improvements, and so on. And finally, we could also run some scenarios a bit differently. So to modeling a country-specific technological changes, so to capture differentials in decarbonization potentials and the respective effects. And last but not least, we could run some sensitivity analysis with respect to some main elasticities. Think, for example, of energy substitution, fuel substitution elasticities in the maritime transport sector, but also some trade elasticities. And we could also run some sensitivity analysis with respect to different decarbonization goals in the maritime transport sector. And this is also due to the fact that the IMO goal by some researchers at least is deemed to be not so ambitious goals. So there is quite some interesting research to look forward in the future, I think. Thank you very much for listening. And now, please ask questions. I'll stop sharing now.
Yeah, thank you very much, Francesco, for this very rich, interesting, and nice presentation. Any question in the audience? I actually had some question about further piece for the, but you it was on your last slide. You have answered all my questions, saying that you are going to manage some sensitivity analysis. Some you were answering exactly all the questions I had in mind. So
okay, so I could have kept talking for a bit longer.
No question. Maybe, yeah. Did you maybe to go in this direction? Did you compare your results with some other modeling exercise that go in the same vein, or not yet? Or
not yet. That is something that, well, of course, we have to do. Like it's very important also because there might be some slightly different assumptions which down the road might have some significant impacts. But as of now, we have not spent much time into looking into other results. Also because methods are generally different. So that's something that we can do later, especially, and then actually try to figure out what is driving these potential differences across the results. But it could also be interesting as another exercise. I don't think in this paper, otherwise it's going to be 100 pages long. But it could also be interesting to basically try to have different models running with very similar assumptions, and then see, how different the results are, or whether the results are different or not. the
EPA model conducts some similar exercises. Okay. Maybe it was on your last slide, but I don't remember. Anna, because there is a question in the chat, and I am supposed as a chair to not monopolize the speech, and but I can't. Okay.
I can try to answer, or okay, I can read it and answer.
Okay, I found it now. So Anna is asking, Norman Lopez is asking, maybe I missed in the presentation, but I was wondering if you will consider potential substitution with other transport sector, air, land, etc.
Yes, thank you for the question. That's something we actually thought about, and that's actually something we are aiming at doing. If I can share my screen again.
Yeah, sure.
But very briefly. So here we actually include, you can see my screen, right?
Mm-hmm.
So we actually included an additional code to the standard GTAP specification, GTAP RD specification. So we are adding some model substitution possibilities in the bilateral demand for transport services. So before it was basically proportional. So the demand for each mode along each route for each commodity used to be proportional to the changes in trade. Whereas what we do here is we add the possibility for actually shifting away from, or at least for some other substitution, given changes in international prices for each mode. And for now, we have started implementing. We have a relatively a simple elasticity of substitution for this. However, there is a paper in literature from December last year, in which the authors have estimated some CES elasticities, model substitution elasticities, for each commodity and along specific routes. So we aim at adding those as well, so that the model substitution is even more detailed for specific commodities. I hope that answers the question. And if not, you're also welcome to get in touch with us and we can talk more about it.
She said yes. Any other question? Or maybe so
Actually, I have a question.
Yes.
Thank you for your great presentation. I'm also interested in the water transport and decarbonization. And I wonder, you mentioned in the final slide, country-specific model can be done in the future. And but I just wonder, when we change the technical change in water transport, how could that be? I think the technical difference among the countries in the world. I mean, some countries use high dependency on water transport, and some countries are low. And some developed countries can adjust. The decarbonization technologies in water transport, but other developing countries cannot. So, what do you think when modeling the differences in countries especially between developed and developing countries, the technical changes?
Yeah, that's, if I get your point correctly, like that is exactly what it would be nice to do, because, for example, there are different potentials between the different decarbonization potential between different countries, right? Even within the same, or even within the same sector, even. So what we did now is the emission efficiency, for example, of the water transport sector, we modeled it at the global level. So we just assume that in each sector globally, or in each water transportation, in water transportation in each country, emission efficiency is increased by so and so much. Whereas what would be nice to do, if we manage to find some more specific data, it could be interesting to look into individual countries or some groups of countries which have different potential changes in energy efficiency, and this could even lead to some different or some slightly different results. Or it could be interesting also just as a sensitivity analysis, for example. But yeah, I hope I answer your question.
Thank you. A question from Wu Sheng Yu, please.
Yes. It's actually a further response as a co-author of this work together with Francesco. I think it's a great question. I wasn't so sure whether the developer country divide would actually be so important at a worldwide level, because if you think about the global shipping sector, maritime shipping, I think this has been dominated by several very large players. For example, here we're sitting in Copenhagen, Denmark. Now we have used to have the world's largest container shipping company, Maersk. I think recently has been overtaken by the MSC, but still it has a share of 15% worldwide of the container shipping capacity. So even in the case of a developing country, when they are moving goods across the ocean, chances that it is these large shipping companies that are transporting those cargoes. So by just looking at how these big companies are doing, actually all these big companies have dedicated teams looking into technical solutions on how to drive this agenda. So I would just, I'm not denying your concern. I'm just providing perhaps a counter argument that by looking at the industry leaders, that will give us some directions on how to decarbonizing this sector and what are the influence on the merchandise trade. But it's a good question. Thank you.
And if I can real quick add to it, even with, so we have like 2, 4, 6, 7 players. They at least in container shipping, I'm seeing here, they take up a huge market share, like more than 60, 70%. But even within those players, or even these players, they will not necessarily, like, they might follow similar decarbonization pathway, but not necessarily the same. So that's some, again, to have some differentials across potential technological changes could be interesting. But yeah, as Wusheng was saying, like there are few players or few major players. So this might be, like the differences might be relatively small. So this might not have a huge impact on final results. But yeah, it's an interesting point that needs to be considered. Thank you.
Alla, do we have time for one more additional question or not?
Yes, we do.
Okay, just concern. So I'll ask it concerning the policy that you have implemented, the instrument that you use. If I remember well, it was an ETS, an emission trading system.
Mm-hmm.
Can you just say a bit more about this and the way you have implemented it? And do you think the result would be different if you have, for example, put a single carbon price without trading? And yeah, what do you think about sensitivity analysis, about the way you implement the policy?
Yes. Thanks for the question. It's something I should have specified a bit better in my presentation.
No, it's okay.
It's so within GTAP actually implementing. So the way we implement this emission trading system is we do not assign quotas to each country, but we set a goal at the world level. So it is equivalent to implementing a global carbon tax on the sector, so that emissions are reduced by 46% compared to the baseline in 2040.
Okay, so there is no exchange between.
No, yeah, I should have explained this a bit better, but it's also like you make a good point. So the way the sector will, and the way the governments will come in and decarbonize the sector, that is also something that at the very least needs to be discussed, because it potentially has ripple effects in the whole economy, well, for the sectors, but also for the economy. So yeah, that adds to the potential sensitivity analysis that could be performed, but potentially it also just adds to some discussion points or some further research to be performed now, how we can achieve the same target through different policies, basically.
Sure. Thank you very much. Thank you for answering the question and for the presentation. So now we'll move on to Andressa Proque, like this.
Yes.
And Andressa will present us a paper that is entitled Tax Elimination on Terminal Handling Charges of the Sectoral Importers, Assessing the Economic Effects in Brazil. The floor is yours, Andressa.
Okay, thank you. Can you see my screen?
Yeah, we see it very well.
Yeah.
Yes.
Yeah.
Please.
Thank you. Hello, everybody. Good morning. Thank you very much for this opportunity. An excellent section. For me, it's challenge because the language. I'm Andressa. I will present my paper together with my professors, Admir, Edson, Wesley, and Aline. I present the scope of our research, the methodology, the main results, and so sorry, just a minute. Sorry. The scope and the main results. This paper is in progress. In the last 5 decades, trade liberation, the development and the diffusion of new communication technologies, and the improvements and modernization of logistical processes have reduced the natural barriers of the international trade and enable the global fragmentation of production processes. So in the same way, production globalization and the expansion of foreign trade contribute to development and of an extensive and complex network of supply and good chains with connected distant production sites with various points of demand through the world. Trade relations between world economies have come to depend not only on the levels of competitiveness of domestic productive activities and on trade agreements that permit tariff and no tariff chains, but also efficient and of the tariff costs charged in the maritime and the port cargo operations in the face of growing logistical requirements. Here, such as, for example, with port costs and the productivity of the sector can make a difference to competitiveness in the world market. In this scenario of business globalization, the issue of trade facilitation emerged in a worldwide trend of reduced tariff and no tariff barriers, which encompasses all direct and indirect costs generated in the import and export operations of a port systems. The trade facilitation agreement itself is evidence of the recurrent concern to seeing the commitments that can reduce the costs associated with the trade of goods through customers around the world, such as simplifying and reducing bureaucracy of producers and eliminate measures that distort the competitiveness of trade products. In less developed countries, such as Brazil, for example, an elimination of policies that can remove these barriers of imported goods, especially import operations, can enable the production of domestic sectors, generate productivity gains by reduce the costs of important inputs, and even absorb and diffuse advanced technologies. Here is a figure. The elimination of this distortion of warfare service has impact of the structures of relative price and production operation, especially in those sectoral activities that are more intensive and important inputs and with great technological intensity. In addition, this tax policy directly impacts the formation of physical capital and knowledge by altering the rate of return and sector investments in Brazilian product systems. This figure, according National Water Transport Agency, the handling charge in the port terminal, the terminal handling charge, THC, is definitely as the price charged for cargo handling service between the port terminal gate and the vessel side, including guarding transitory cargo for the period contract between the maritime carrier or its representative and the port facility or port operation in the case of exports, or between the side of the vessel and its placement in the terminal stack in the case of imports. The definition is linked to the missing of the customers by a specific law here in Brazil, which defines all stages of activity of moving goods and the facilities inside the port, such as receiving, checking, internal transporting, opening of volumes for constant checking, handling, storage, and delivery, as well as the loading and unloading of vessels when carried outbound equipment. So this is this paper to analyze the economic effects to an exclusion of the port foreclosure tax, THC, on the basis for calculating the import tax on the Brazil economy, taking into account the redistributive effects on the country's productive composition and technological basis. The elimination of this tax distortion has impacts on the structure of relative prices and production operation, especially in sectoral activities that are more intensive and import inputs and with great technological intensive. The inclusion of this tax inflates the cost of imports and affects business conditions and sectoral competitiveness in the country's domestic and the foreign markets, as well as controlling the world trade and trade facility. So removing distortive barriers on imported goods, cheaper import inputs, dropping product costs, product increase GPC, technological change in relative price, great competitiveness, effect on production, income, consumption of families, change the cost of capital production, improve private participation. Here's a Brazilian party system. Right? The party system in Brazil is made up 34 organized public parties and 147 private use terminals spread over a coastline of 7,367 kilometers. The main organized ports in the country here in Brazil is Santos, Paranaguá, and Itaguaí. The TUP is a port facility operated under authorization and located outside the organized port area. About the regulatory framework is centralized at the National Secretary of Ports and Water Transport, and this specific agency of here in Brazil oversees the contracts and monitors the operational performance of the Brazilian port systems. Estimate of the THT port cargo handling about this specific law, import cargo load by long haul, as there is no statistical and public information to assess the relative weight of THC expenditures of the country's import tax base. In this variant, this paper contributes by estimate the share of port operations imports landedly by long distance navigation with the Brazilian foreign trade agenda, and this estimation involves the compilation of a large volume of statistical data in a history series between 2010 and 2017. Here is a figure about the estimates of the THC cost by sector, physical load, the agency data, port facility, navigation type, load profile, sense, cargo operation, part X prices, waterway access infrastructure, operation, ground infrastructure, and costs about the period, this work. The table shows the table shows annual average of import indicators. The cost of import the port size represent on average 0.64% of the current value new exports, defined by difference between the monetary value of imports and the port cost estimated value of agricultural and industrial goods. This is the corresponding share of the port for a closed shore in relation to next imports in Brazil. The annual fluctuations of these indications depend on several factors, such as variations in the composition of cargo unload in Brazilian ports, changes in the choice of ports of the purchaser, changes in price charged, variations in the company's operation in the port system, and as well as the economic situation each year. Among the imported goods, the extractive industry products would be those with the highest cost of for the close shore on an annual average in the period 2010 2014 17. Intermediate inputs here in turn reached almost 46% of total the imports of industrial and agricultural goods during the period evaluated. And this average cost of Brazilian posts per direction in this period. These are the TC import costs by stated by extractive industry here and transformation industry, and this map shows the TAC cost BR million Brazil, the most areas here, the most cost. To evaluate these works, I use a recursive dynamic computable general equilibrium model. Is a national model, country for Brazil, based here. Which includes capital, accumulation holes, investment, allocation, and salary adjustments with lag. Traditionally, CGI models allow variations in relative price, capital substitution effects in certain markets, consider supply and demand side relations, and recognize the direct and indirect effects on the economic system. This CGI model specific, these studies, take into account a fiscal balance of payment. You use a social account matrix for Brazil economy, as well as explicit stock flow relationship between research and development, and no capital in the structure, theoretical data. The models called being Brazilian intersectoral model, and this model represents an extension of other models in applied research. Analyze strategy, this specific reduction of the customs tax rate on the price of important goods, which determines the tax base of imports in the country in this period. This strategy of this study consists of apply a reduction shock on the price of imported goods in the tax base to simulate the policy. This study implements annual shocks from a policy of reduce the customs duty rate on the price. The strategy of the study consists of apply a reduction shock because the main objective of this paper is to analyze the economic effects on the exclusion of TAC in the calculation base of the import tax in the Brazil economy, taking into account the redistributive effects on the product consumption and the technological base of the country. About the results, this table presents the impacts of the policy in the main macroeconomic variables like GDP. It is observed that policy would generate positive effects here on the growth rate in Brazil, gross domestic product GDP in the medium and in the long term. In the terms of the expenditure side, the positive effects of the components of internal absorption of domestic goods would more than offset the negative contribution here in net exports to the impact of the policy on GDP in the long run. The marginal deficit in the trade balance would be justified by the relatively lower growth in foreign sales between the period, as the term of the trade will grow by 6.84%. On the domestic side, household demand, household consumption would accumulate 4.87% in relation to the trend scenario, contribute with 3.15% of the 3.8% of GDP in the long term. Gross capital formation here with encompass physical and knowledge will be main component of expand international absurd hierarchy set 0.84%. As shown in the table, the change in the tax policy without the foreign cost would imply and 7.84% increase in physical capital investment and 2.81% increase in research and development here. About the effects on sector activities in this table presents of sector activities according to RCD's classification of technological intensive. And the graphic illustrated the evolution of investment and capital stocks of the private sector in Brazilian production systems. Here, medium height and high technological industries would be those that would most grow investing in the economy. The supply of goods from these two categories of industrial activities would accumulate a positive deviation for 0.7% and 4.31% with positive impacts. The sectoral projections also indicate that the policy would contribute to a relative increase of the private sector in the country's production composition. Private investments in physical capital and in research and development will show an upward and regular trajectory in the medium and the long term accumulation of total 8.17% and 5.3%. And so in the accumulation impacts, even with great penetration, the competition from important inputs to the Brazilian economy, the impact on the policy on domestic activities will be positive and when spread in the long term. Sectors more linked to gross capital formation and which are among the most important in the country's technological base will grow relatively more, such as civil construction, electronics, electronics, machinery and equipment, and auto vehicle, and other industries here. So, the elimination of this tax distortion has impacts on this structure of relative price and production operations, especially in those sector activities that are more intensely important inputs and with great technological intensive. The tax policy directly impacts the formation of physical capital and knowledge by altering the rate of return of sector investment in Brazilian production systems. The volume exported would increase and the export basket would become more diversified with a relative growth in the share of manufactured product in foreign trade. These projections are with the objectives of Brazilian trade policy, which is intended to increase the share of manufactured goods in the country's trade flow. And in countries with insufficient domestic supply of inputs to meet the process of physical capital formation, the facilitation of imports would also meet the part of the domestic demand and complement the national supply. So thank you for this, and so sorry for my language, and this is thank you very much.
Thank you very, very much, Andressa. Very nice presentation, very interesting. Any question or comment, please?
Can I ask a question?
Maybe first Mark Horich and then Byeong-ho. Okay.
Well, first I would say parabéns, Andressa. And I think at one point you referred to Brazil as a less developed culture. And this makes me very annoyed because I know that, for example, Juiz de Fora is the world capital of pork crackling or torresmo. So how can you say this is a less developed country? Brazil is a middle-income country.
Yes, thank you, Mark. Thank you for the comments. Thank you for the comments. Oh my God, I'm very nervous because the English, so sorry. But thank you for the comments.
It's okay, your English is perfect, okay. Don't worry. Byeong-ho?
Yes. Thank you very much for your great presentation. I think it's a very interesting topic to eliminate the THC handling charge. We mostly deal with tariffs, importing tariffs, but I think as your research, I think the THC reduction also plays a similar roles in international trade, and I'm just wondering when you do your simulation, did you reduce the THC levels all over the world, or just Brazil?
Just Brazil.
Just Brazil.
Yes, and they use a national model here for Brazil, and not use the GTAP, for example, but just reduce the tax for Brazil in this study. Yes. But I think it's very good idea to worry about the other tax, for example, to compare other countries to Brazil, for example.
So in your research, reducing only Brazilian THC is like reducing only importing tariffs of Brazil. And even though that the outcomes of simulation is positive, the GDP, the outputs, and all the major economic indexes are positive. So I think it's very interesting.
Yes.
And yeah. Thank you.
Maybe. Thank you. Maybe for future researches, maybe wondering use other models, for example, GTAP, because this model just a national model, recursive dynamic for Brazilian economies. So it's possible now reduce the tax just Brazilian because the model is national. But I think it's a good idea to worry about the other countries and maybe to analyze it in other models for other countries. Yes, I think it's a good idea. Thank you.
Thank you.
Any other question? Okay, so thank you very much, Andressa, for the very nice presentation. And now we are going to move to Zhan Wang, who is going to present us the paper that is entitled Transportation Cost, Agricultural Production, and Cropland Expansion in Brazil, a multi-scale analysis.
Thank you very much. So hello, everyone. I'm Zhan Wang from Purdue University. Today, I'm glad to present our work on the impact of transportation costs on the agriculture and the cropland expansion in Brazil. So if you review the development of agriculture in Brazil in the past 3 decades, we will find that there are 2 important patterns. The first pattern that there's a rapid increase in both the total output and also the productivity in Brazil. And the second pattern that there's an expansion of cropland from the traditional agricultural area in the south to the inland central west region of the Cerrado region that is shown here. So here we take soybean as an example. From the figure from recent published literature, we can find clearly that from 1995 to 2005, the output of soybean increased by threefold, and we see the soybean area is increasing dramatically in this Cerrado region and also part of the western Bahia state. However, this Cerrado region is also the region that we have the higher transportation cost. So here I show the map of transportation network in Brazil with the baseline year of 2017. So as we can see, the Cerrado region that is shown here, it has the sparser transportation network compared with the south and the southeast in Brazil, and also the infrastructure condition is poorer in this region. And furthermore, this area is more far away from the exporting ports that are located in the coastal area on the south and also some of them on the north. So as a result, the literature has found that the transportation cost in the Cerrado region is much higher. So that is equivalent to up to 28% of the FOB price, especially in the state of the Mato Grosso. So because of the pattern of crop production expansion to the Cerrado region and also the high transportation costs in this region, we conclude that the high transportation costs within Brazil can play a very important role in the agriculture of Brazil now and the future. So when we consider the transportation cost is high, it increased the price weight between the FOB price and the price at the farm gate. So it lowered the farmer's revenue. And because farmers cannot afford enough input, so the high transportation cost also leads to the lower yields of crop production. And the lower yields further undermines the competitiveness of Brazil's crop export. And another implication on the agricultural land is that, so if we can reduce transportation costs, that will help to increase the yield and saving the cropland needed according to the Bullock's hypothesis. However, the Zhan paradox also indicates that the increase of yield may instead require more land to be used for agriculture, which can cause the conversion of land use and the deforestation in Brazil. So the impact of transportation on Brazil, both for the agricultural output and also the agricultural land, is an important research question. So according to the existing literature, they already identified the relations between the transportation cost reduction and the deforestation from both modeling and also the empirical analysis. However, there are still some limitations in this existing literature. For example, they tend to focus on only a specific region, but overlay the interactions with other regions in Brazil, or some of the micro level drivers on the national level or from global level are ignored in these studies. And also for many of the studies, they tend to use traveling time as a proxy of the actual transportation cost. And they tend to do the analysis on the more aggregated level, for example, national or state level, but lacking the spatial details in analysis. So in order to fill the gap in the literature, in our paper, we make the following contributions. The first, to our knowledge, it is the first study that try to link in the micro drivers with the local heterogeneity and also local transportation cost change in Brazil. And also, they are using a grid receiving model to capture the spatial variance of cropland production in order to have a more accurate result. And finally, here we're following the global to local to global channel that linking the linking the local response with the external micro drivers. So the policy background of our research is that so Brazil has released the National Logistics Plan, or in short for PNL in Portuguese. So according to this plan, comparing with the baseline year in 2017, by the maximum improvement plan of 2035, it will have the length of road increased by only 0.5%, but the railway is expected to increase by over 90%. As we can see here, the increase of the railway will mainly happen in the Cerrado region. And we wonder how will be the infrastructure improvement from PL influence the agricultural product and the cropland in Brazil. So in order to research that, we take the PNL change as our policy scenarios and calculate how transportation types, distance, and cost will happen when we considering the maximum improvement scenarios in the PNL. And secondly, we put that transportation cost reduction and also as other socioeconomic drivers into the Great Soybean model, the Simple G Brazil model, and to simulate the response of crop output and cropland both on grid level and also on the state and national level. And finally, we consider what will be the implication of transportation cost reduction on the carbon balance. In order to research that, we are going to simulate the change of CO2 equivalent emissions from the transportation vehicles together with the change of carbon storage from the vegetation and land use change, and to have combined together to have an overall evaluation of the impact of carbon balance. So here I provide I described the method we use to calculate the transportation cost in Brazil at the grid level. So the first step is that we are going to collect the base data, including the transportation network, both for the baseline year and also for the future. And also we take the land cover data from the MODIS land use data set and also the elevation data set. So all the data shown here are then rasterized and combined together at the resolution of 30 arc-second level. In the second step, we assign a speed of transportation based on if each grid is located on the transportation network or not, and if not, what is the land cover and what is the elevation and the slope, to have a raster of the transportation speed, and then we take the inverse of that and represent that as the transportation friction, which is defined as the time used to move 1 meter in each grid. That is shown on the figure on the right-hand side. So in the third step, we consider the transportation from each of the macro region that is equivalent to the county level in the US. And here, the origin is considered as the centroid of each polygons of the macro region that is shown on the figure here of the grid polygons. And we consider the destination of the exporting port that are represented as the yellow stars. So even if we are using the exporting port as a destination, we do not assume that all the crops will be exported. This is because we are lacking the information exact location of the domestic demand of the crop. However, we know that in Brazil, the most developed area is the area in the southeast that is also close to the ports here. So we think that the destination of ports can also represent the demand of domestic crop demand. And based on the destination and the origin destination, we're using the friction surface to calculate the optimal path with the least accumulated friction algorithm. And from each path, we can separate that to be the transportation on the road or on railway, and convert the distance to cost based on the observed cost to distance relation. And finally, we calculate the cost for each port, for all the ports of each origin, and select the least cost of the measurement of our transportation cost. So how are our results? Are this method accurate or not? In order to validate our method, we're using the observed data about almost 3,000 observations from the National Supply Company, which provide us the real-world transportation distance and cost, and we are using our method to estimate the distance and the result, which is shown as here. So from the figures and the regressions, we can conclude that our estimated distance and the cost has a close to 1-to-1 relation with the real-world data, and we have the R-square of the linear model to be both greater than 0.8. That indicates that our method has a good performance in recovering the transportation distance and the cost in Brazil. So also we're using the simplified international model of agricultural price, land use, and the environment, the greater version for Brazil, or in short of Simple G Brazil. Simple G Brazil is a grid resolving partial equilibrium model that we focus on the crop production and input use. So for Brazil, we downscale that to over 50,000 grids, and we aggregate the rest of the world to be 16 regions. The baseline year of this model is in the 2017. So based on the transportation improvement from the PNL, we consider two scenarios of transportation cost change. The first is that we assume transportation costs will reduce under PNL's maximum improvement plan that we call the TCR for transportation cost reduction scenario. And secondly, we consider the transportation cost remains at the 2017 baseline level. This is called the basic neural scenario of the BAU, and we also consider the projection of social economic drivers, including population, GDP per capita, and technology improvement according to SSP scenarios for both Brazil and the rest of the world. And we are projecting the agriculture of Brazil to the year of from 2017 to 2050. So here we show the results of transportation cost calculation as the baseline, both in the monetary term and also as the share of the FOB price. So here we can say in general, the transportation cost in Cerrado region has a higher transportation cost, which is equivalent to around 30% of the FOB price. That is consistent with the existing literature. And when we consider the transportation costs under the TCR scenario, we see a huge reduction in the Cerrado region, especially in the center of the Mato Grosso and also in the part of the Bahia that the transportation cost is expected to decrease by 20 to 40%. And when we consider the impact of transportation cost, it is measured of the change from the BAU to the TCR scenario. On the national level, we only find that there's a tiny level change. And the TCR scenarios, the crop output and the crop land use will both increase, but that is still less than 2%. So the change is very small. However, when we consider the impact of the state level, we see that the state of Mato Grosso has a huge change, almost 80% comparing with the BAU scenarios, followed by the change that is 24 for Bahia state, comparing TCR and the BAU scenarios. And in order to understand what are the drivers of the change of crop output, we further decompose that as the direct effect from yield change, from cropland change, and the compounding effect from these two. So here we can find that because Mato Grosso and Bahia state, they both benefit from the reduction of transportation costs. So their farmers in this state, they can afford a higher amount of the input. So the more input will drive the yield to be increased by a lot in these two states. And for the Mato Grosso, we also see a higher response of the cropland extension. That's because that Mato Grosso is the agricultural frontier area of Brazil. So the land supply elasticity in the Mato Grosso is higher. So the response of cropland is also stronger. And for the rest of other states, other major states with higher cropland, because of the increased demand of inputs, also increases the price of this input. So that drives the other states to be using less input, both for land and land. So we see the reduction of both yield and also cropland in these regions. And furthermore, based on the results on the grid level, we also find that there's a variance not only across states, but also within states. For example, we see the higher output in the central of Mato Grosso and a tiny level decrease for the other regions that are not benefited from cropland production, crop output reduction. And finally, we consider the impact on the carbon balance. So because transportation costs, because the transportation on the railway is more efficient, both on the cost and also on the CO2 emission. So when we have the higher expansion of railway lines, especially in the Cerrado region, then the transportation structure will depend more on the railway than the roadway. So we see a larger decrease of CO2 emissions from the roadway from TTR to BAU, while the increase of emission from the railway is only increased by a lower percentage, lower amount, resulting a net decrease of CO2 equivalent emission. However, as we show from the previous slides, this transportation cost also results in the expansion of cropland in the northern part of Brazil. So if we taken the impact of carbon storage from vegetation into analysis, we find that due to the expansion of cropland and land conversion, we also have a huge loss of the carbon storage from the land use conversion. And if we put it together, then that impact is greater than the net reduce of CO2 equivalent emissions. So it overturns the output from the benefit to the worth of the net impact of transportation cost reduction. So as a quick summary, so in this study we found that the transportation cost in the Cerrado region can be as high as around 30% of FOB price. And if we consider the TCR scenarios, we will expect the transportation cost to be lower by 20 to 40% in both the Cerrado region and the West Bahia. So with that reduction, it helps to increase the yield in these regions. And also we see the expansion that happens in the Cerrado in the Mato Grosso, mainly due to the higher supply elasticity of cropland. So another finding is that we find that the impact of transportation cost is also varies within each state. It indicates that it's important to consider the spatial level heterogeneity into our research. And finally, if we only consider the impact on CO2 emission from vehicle, it is beneficial for the climate. However, the impact on the carbon in the carbon storage offset its effect. So it indicates that when we are going to do the comprehensive analysis of the CO2 of the carbon of transportation cost reductions impact on the carbon balance, it will be very important to consider the economic response into analysis. So this is the list of reference. Thank you very much, and I'm happy to take questions.
Thank you so much, Zhan, for this very nice presentation. Any question in the audience or comment? Okay, maybe I can start with one question. If I have well understood, if I have well recalled, the model you have used is a partial equilibrium model. Okay, and so are you envisaging considering to link it even softly with a general equilibrium model, or is it something that you don't have in mind at all? This is the first question. And the second is also, this is a regional, specific to one region. Are you considering further work to duplicate this kind of model, but to other regions? Why this region in particular? And
Okay, thank you very much. So for the first question, yes, the simple Brazil model is a partial equilibrium model. And when we are building the model, we take the partial equilibrium way, but instead of the CGE way is that now we are still some uncertainty about how will be the whole circle of the response from the change of the input factors to the supply of that within the whole system. So instead, we are using a exogenous shock from the population and the GDP change to that. And so for now, we have no plan to extend that for the CGE model, but maybe we can consider to linking that with another CGE model in order to provide some dynamic exogenous shocks on the factor supply. And for your second question, so yes, this model is based on the Brazil itself, and for the other regions, we aggregate them to be also only on the region level. So besides the simple Brazil model, currently we also have other versions of simple D models, but each of them with a specific focus. For example, in another model, we have the US to be downscaled and the rest of the world to be aggregated, and all we have the China to be downscaled and others to be aggregated. The reason that we choose to downscale and focus on one nation is that we would like to take advantage of the more detailed information from that country, because we know that basically the domestic data is volume and also its quantity is generally better with some of the global analysis. So hope that answers your question.
Yes, thank you very much. Any other question or comment? Okay, so maybe this that wraps up our final presentation and discussion period for this session on transportation. So please, you can help me in thanking our presenters for their valuable and thought-provoking presentations. We appreciate everyone joining us, and hope you enjoy the remainder of the conference. And just to tell you also, Francesco Clora had to leave. He apologized, but he left me a message saying, asking me to thank you all also for all the very nice, rich presentations. So the session is closed, and thank you very, very much.